Hello, everyone. I'm very proud to introduce the very first presentation of the evening. My name is Veronica. I'm the coach of the legendary iPic team. And now I hand over to Ivan and Martin to tell you about our truly incredible project. Enjoy.
Welcome, iPraktikum. My name is Ivan Garza. We're the iPic team. And we're developing this hardware-software system for the classification of behavior of free-roaming pigs. But before everything, let me introduce to you the herd. In the bottom line, you can see all of us, the developers. We had the pleasure of being led by our great coach, Veronica, and our very experienced project leader, Juan. We also had the pleasure of working with our local support Dr. Nuske, and of course, our customers all over in Zambia, Professor Isaac Firi and Dr. Chomi Sikasunge, plus the extra remote support of Lee and Thomas. But before I tell you anything else, let me show you guys the trailer.
Kevin!
I was expecting some applause. Thank you. So let me introduce the problem to you. Our problem is very complex, yet a little bit clear. There's a lack of control over free-roaming pigs in Zambia. Farmers don't know what their activities are, what they are eating, or how are they doing health-wise. And because of this, they are in constant danger of getting the unpronounceable disease of cysticercosis. And based on your look, Professor, I can only assume I just mispronounced that. And also, they are always in constant danger of getting kidnapped or of dying when they are out in the wild. So, when I signed up for this project, I thought I was going to do some software engineering, of course, but instead we were presented with this complex hardware-software system problem, and clearly the problem of the global customers and the remote customers and the global project. And because of this, we decided to divide the project in three. We realized that we would have to develop a sensor unit for tracking the activity of all the pigs. We would have to recognize all of this activity and try to classify it in an understandable manner. And finally, we will have to visualize it for the farmers to be able to recognize what the pig is doing and how is it doing. So like I mentioned, we divided the project in three. We decided to have three different modules. We decided to have a sensor module, an analytics one, and a visualization module, which I will present shortly. And obviously, all of these modules came with their distinct and special requirements. Starting off with the sensor module, we had to take in consideration its energy consumption, of course. We had to take into consideration how comfortable it is for the pigs, how robust it is between some other things, And we had the functional requirements of gathering the data and sending it to the next analytics module. This analytics module's job is to interpret this data and classify it in a proper way to then show it on the visualization module, which job is to visualize all of this data in a clear and presentable manner. And if explaining the project wasn't boring enough, here comes the models, our favorite part. For the analysis subject model, we have a lone pig as our protagonist, which is part of a herd of many other pigs. This pig can be doing very different activities, for example, walking or standing. And it can be in many different areas. And we divided these areas in different spots. For example, the spot where the pig is eating. So we're using this sensor package. We're doing this sensor package, which contains a notifier which tells the farmer what the pig is doing or when it found strange activity. And this sensor package consists of three main components: a sensor for acceleration, a sensor for rotation, and a sensor for location. And specifically, we're using an accelerometer, a gyroscope, and a GPS. And I will now pass along the microphone to my colleague, Martin Frank, who will explain the system design for you. Thank you.
Is this working? Yeah. Okay, thanks, Ivan. So now for the system design, we will only consider one pig, not the whole herd. The pig also is equipped with a sensor which tracks the location, orientation, and acceleration data. And the sensor subsystem also has a sensor case, a battery, and a storage unit, of course. From there, the sensor data is passed on to the transmitting unit and forwarded from the transmitting unit to the analytics subsystem, where our classification mechanism takes place and the notification mechanism, and also all the data, the raw data and also the already processed data is stored on the archive. From the analytics subsystem, the aggregated behavior and activities have to be passed to the visualization subsystem for the user, so he has a representable overview over the data and can analyze what his pigs are doing. So then the user also can manually update the pig data, which means he has to synchronize with the sensor and had to push his updates again to the analytics archive. So now we have a lot of different subsystems to work on simultaneously. So to start working on them all at once, we decided to go for a test environment. For financial reasons, and I guess also because we are the iPraktikum, we went with an Apple Watch for the sensor. The Apple Watch passes the data to the Wi-Fi router and then to our virtual machine, where our classification takes place, and we visualize the data on the tablet, on an iPad in our case. Of course, this worked well for us for testing, but in Zambia, our target area, this would not be feasible, of course. So we had to take in some more different design proposals. For example, the biggest requirements that we had there, or that were most conflicting, were the energy consumption against the network connectivity, so the live updates. Is it live updates or offline storage? So to show you this, first we go, where is the data? Is the data either stored on the sensor, which would be on the data logger, so there will be low energy consumption, of course. On the other hand, we won't have live updates, which will come later. On the server architecture, we will have a persistent set of data, and we would have remote access to it. The next thing we have to think about is where would the actual classification take place. So we can classify it also on the server, which would again go for the live updates, or do the computation on the sensor, which would only do periodically for unusual data would be pushed to the notifications, or we do an offline computation, which would basically mean after the fact insights. So we had the Apple Watch already in our test environment. We are now trying to go for either the micro hub, which is just like a custom chip with the GPRS module, or as a data logger. So now that you know about the sensor, we also had a lot of requirements to the sensor case. So the first thing we went with was just a custom off-the-shelf product, a Tic Tac box. To remind you of the requirements, we have the robustness, the comfort of the pick wearing the sensor, and the safety of the pick. So we actually faced some minor problems with this first approach. So pigs are rather curious, so they would bite the sensor off. They could harm themselves, of course. So comfort was good, robustness, safety, not. Next up, we went with a custom-made 3D printed sensor box. It looked robust, but it still broke, and also was bad for the safety, and also it was a little bigger. So what we learned from this prototype was that we had to use another material if we would go for 3D printing again. So what we are doing now is we go for a micro-hub sensor case, and we already shipped one of those to Zambia, actually. We already know that it goes well with the comfort because it has an even smaller size as the Tic Tac box, but we still have to test the robustness and safety of it. Now that you know the amount of the sensor box and the sensor case, the sensor subsystem, we still have the analytics module to talk about. So basically, we collected some data and we labeled it, 5,000 recordings approximately. We trained it with supervised learning and used K nearest neighbor classification. And what we got out is a 90% accuracy and the execution with the server delay. We are using, remember that we use a server architecture right now, so it has to go up to a server and down, takes 3 to 5 seconds. But enough talking, Moritz is here and will show you in our demo.
Thanks, Martin. Yeah, good afternoon, everybody. I've got some good and some bad news for you. The bad news is that due to legal restrictions, we were not allowed to bring a regular pig on the stage as we wanted. But the good news is that we found a very rare Siberian husky pig that we will use instead. It's upstairs waiting. There we go. But turning back to me, actually, so it looks like my clicker isn't working.
Works always.
Works always, awesome.
Enjoy.
Thank you. So there we go. I'm gonna open the application actually. And the first thing I'm gonna see is on the left side, the list of my picks that I've entered, including the name, a nice short image, and the current status, what they're doing, including a notification bubble, for example, for Miss Piggy, if she's actually doing something strange, cautious, suspicious. On the right side, we can see a map actually, a map of the local surroundings where we can see the location of the animals, as well as an overlaid heat map, which shows the different areas where the pig are doing different things. So the farmers can easily spot where is the pig eating, where is it sleeping, where is it pooping actually, which is an important thing for this disease we're trying to fight. So we need to find out where is the pig doing what, and we kind of try to visualize it like this. And for this demo, actually, we make a risky live test because it's not just about showing where's the pig doing what, it's also about showing what is the pig actually doing. So I can check it out, and we can see actually the pig is currently resting, our Siberian pig. And let's check it out, it's coming down now, what it's saying. It's saying not much. Oh, there we go. There is, of course, a small delay because the whole data gets sent from the sensor, the actual Apple Watch the dog is wearing, through our analytics system in the cloud, and then getting back transferred to the iPad. Maybe, do you want to do it once more? Run. There we go, there we go. So, yeah, thank you very much, Ivan and Kenai, for the sportive performance, and I'm going to hand back over to Martin.
Thank you, Moritz. Is it on? Yeah. Okay. So then to our current status. So on the sensor module, we already analyzed several design proposals. We have gone through several case iterations, and we have the activity tracking working on the Apple Watch. Now we want to transition this progress, of course, to the micro hub. On our classification, we already can classify walking, resting, and you also saw running, but that was just like a test. Maybe we will integrate it. And we still would have eating, pooping, and some other. Also, we have to collect this data, of course, label it again, and we still have to figure out how do we actually distinguish abnormal data from this real data. For the visualization module, we already have the state visualization and the heat map, but it still lacks the actual functionality of the location data of the pig. And we still have to do the analytics dashboard, of course, and present the user with more features. We are happy to take on this task in the next 4 weeks after we recovered from this one. And yeah, that's basically it. I hope you liked it, and thank you for your attention. Do your customers still have questions? Do we have a connection?
Hello, we connect. We can hear you. Perfect. We were.
Yes, we have a few. Have you not finished though?
Yeah, I think it's because of
Oh,
the
the delay. Okay. Nice to be able to speak to you all.
Hello, Bernd? Sorry, maybe Bernd. Hello.
Hi.
Hello.
Yes. Yes, it's lovely to. Hello. I have a couple of questions for you. Firstly, I know you haven't. It doesn't sound like you started to field test the latest case yet, but I'm just interested in how you feel you might.
We are trying to make a stable connection to ZAMBIA. For delay.
And sort of ruggedize it onto the ear tag.
Hello. Can you hear us, Bernd? Okay.
Okay. So our first question is about.
Actually, we haven't put.
This is your connectivity.
Okay.
It's a normal phone call. You just
Okay.
put it on your ear. Is there a chip on there? No.
No.
Just put it on there.
Okay. So, to make it waterproof, actually we haven't put much thought into it because we face different problems. But basically, we would first go with some kind of material to damp the inside of the case, I guess. Thank you.
Lian,
Good luck with that.
do you have another question? Okay, so the question is, can they download the raw data that you use for classification?
Yeah, sure. We will make it available for you. She heard it right.
Okay, so it'd be easy to put it, say, into ArcGIS or similar.
Yes. Yes.
Okay, thank you.
Okay, thank you very much.
Thank you.
It's been quite an experience here. Thank you.
Already.
Going.